Assalamu alaikum everyone. My name is Mohammad Arham, and today we are making a video of the simulation of final project of the course of microcontrollers and embedded systems. Uh, in this project we had to interface a line following robot called ZUMO with an SD card, and what we had to do in that was to store the path and the movement of a line following robot in a file in the SD card. So that was a project. Let's see the details. This was our final project submission link, and here we had to modify our code according to the path that was already given to us, and we had to interface an SD card uh, with the line following robot and the microcontroller, so that the path that was being followed by the robot is stored in that. In case you are wondering that it is missing, our deadline for the project was extended from 22nd January to the 25th January, and that is why it is showing missing. So anyways, let's move to our project. So here is the previous design of the line following robot project. In this project we have used a microcontroller, ZUMO line following robot kit, an SD card and a virtual terminal. The ZUMO line following robot is basically a line following robot which is being designed by a company named Pololu, which manufactures these line following robots, and our only purpose is to buy those robots and program them accordingly, according to the path and according to our needs. Similarly, that is the thing that we have done here. The path was already assigned to us. We have just modified the code, and the additional thing that we had to do was interface an SD card with this line following robot, so that every movement that the robot follows is being stored in a separate file in the SD card. That is why we have used this SD card to store the data. We have also used a virtual terminal to display all the messages of the whole process that is being done, so that it does not go unsuccessful. So let's start it. The SD card is properly inserted in it. The simulation is running. As you can see that it is showing that initialization was successful. This path was already given to us by our course teacher, and we had to modify the robot accordingly. As you can see that I was given the heading of ZUMO simulation project. Since it was our project, then it is showing my name and roll number, and then as the SD card is properly inserted, it is showing that initialization was successful and it is ready to write the data and information on the SD card. I have also used the other condition in case the SD card is not inserted in the SD card slot. Let's see that also. Install the simulation. We have removed the SD card, and now let's run it. We will see what happens here. Simulation has started, and yes, it is showing an error which says that initialization failed. Please insert the SD card, and the file failed to open. As the SD card is not inserted in the slot, so that is why it is showing this whole message. This was the other condition that I had introduced in the program. Now let's insert the SD card and again start the simulation. The SD card is inserted. Let's start it. The simulation is running. simulation was successful and it is ready to ride. So this is the button for the starting of robot. Let's start it. So the robot has started to move. First, since it is moving straight, it is showing straight for S for straight. Now, as it took a left turn, it is showing L for left. Now again, there is a left turn, it should show L. Yep, it is showing L again. As it takes a left turn, it is showing L. As there is no path ahead, it will move back. So it moves back and showing B, and it moves straight, so it is showing S. Again, as there is no path, it will move back. Now it took a left turn, and there is a right turn, so it is showing R for right. Now again it will take a turn here, left turn. Now again it should move left, L. Yeah, you can see that all the movements and readings are properly being shown, and these are being stored in a file. So it is taking the proper turns, and it is showing all the turns that are being taken here on the virtual terminal. So this was the purpose of using virtual terminal, that all the readings and movements are properly being shown, and no fault was taking place in this whole process. So again it moves back, and now it will take a left turn. It takes a left turn. Now again it should move left, and as it reaches the end point, it stops. So this was the whole process of movement of robot, and following the black line only. So I followed the whole path and reached its endpoint. Now let's see the details of our simulation. Let's stop the simulation here. So we have used a microcontroller. As you all know, that microcontroller is like the brain of any project, you can say any robot. Yeah, so here is a microcontroller. Here is the SD card that we have interfaced. We can see that we have interfaced the chip select pin to the IO10 pin of the microcontroller, the IO10 pin, which is the PB2. Then yes, one thing more, for storing the data, we have used the SPI interface, serial peripheral interface. So let's move forward. The data input pin is connected to the master out slave in pin on the microcontroller, which is the IO11 and PB3 pin. Similarly, the meso pin, master and slave out, which is the data out pin, is connected to the IO12 pin of the microcontroller, which is PB4, and the clock pin is connected to the IO13, which is PB5. Similarly, all the pins of the ZUMO robot are connected consequently to the microcontroller. This is the ZUMO sensor reflector array that senses the black lines and sends the readings accordingly. So these are the pins that are connected to the microcontroller. This is the ZUMO button for starting the movement of robot, and these are the motors accordingly. So this was all about the design. Now let's move towards our source code. So this is the source code for our project. First of all, we have included all the libraries that are important for the working of this robot. We have used QTR sensors library, then ZUMO reflectance sensors array, that was an array in the ZUMO schematic, and then we have used a ZUMO motors library for the movement of the motors, then the ZUMO buzzer, and then a push button for starting the robot. And then we have included a library for SD card, that was the main purpose of our project. And as we have used the serial peripheral interface, so we have included that library also. Uh, hash include wire.h library was not as much important and required in this whole project, but uh, without this library our project was not working. I also searched on the internet whether this library was important for the SPI interface that we have used here, and all of the links that I read were showing that wire.h library is only important for I2C and other interfaces. So I don't know what was the issue, but without this library our project was not working, it was showing an error. So anyways we had to use it, so here it is. And then we have included the servo.h library. First of all we have made a file with the name my file, and then we have used the chip select pin to the 10th pin of microcontroller that I told earlier. This is the chip select pin which is connected to the IO10 port. So this was it. Uh, the port chip select. As we move ahead, we have made a function for SD card initialization. This was the main function, the main purpose of our project that we had to modify. Again, I'm telling you, now as you can see that we have defined sensor threshold value which is 300, and then there is another above line function which is defined. Above line is a helper macro that takes returns if the sensor is over the line and 0 if otherwise. These were all already given in the ZUMO simulation. We only had to modify this according to our path and according to the SD card interface. So similarly we have defined the turn speed 200, and then the speed is also defined 200. The these are all the details that are given. Motor speed when turning, and motor speed when driving straight. Speed should always have a positive value, otherwise the ZUMO will travel in the wrong direction. And then we have defined the thickness of our line, which is 0.75 inches. And then we have used a conversion inches to the units, which is 17142.0 multiplied by 4.0. And then when the ZUMO reaches the end of a segment, it needs to find out three things: if it has reached the finish line, if there is a straight segment ahead of it, and which segment it takes. Overshoot tells the ZUMO how far it needs to overshoot the segment to find out any of these things. In overshoot, there is line thickness inches to z units, and multiply by line thickness divided by speed. And then as we move ahead, ZUMO buzzer, these are all the functions of the library that we used earlier. This is the function for SD card, SD file root. So as we move ahead, these are the characters for path. We have set it to an array of 100 size, and the character path length is 0. Then comes the void setup function. Here we have displayed all the initial messages that were being shown. As you saw earlier in the simulation, during the simulation these were the messages that were being shown at the start. Now we have initialized the SD card function, so let's move to the SD card function. This is the SD card function. We have set the pin mode chip select, that is output, and then we have used an if loop, if condition uh, for uh, for if the SD card is not properly inserted in the SD card slot, it will begin the chip select, and it will display the messages that initialization failed and please insert SD card. As we saw earlier in the simulation, let's see it again. Now, let's remove SD card. SD card is removed from the slot. Let's start the simulation. The simulation has started, and these are the initial messages. And yes, as you can see that initialization failed. Please insert the SD card, and the file is failed to open. It is because there is no SD card, so it has no place to write the data. So that is why it is showing the message. Now let's stop it and see the code. So this was the if statement, and if that statement takes place, then it will display the initialization failed and please insert SD card messages. Else it will display the message that initialization was successful, only in case that the SD card is inserted properly. And as we move further, uh, SD card will open the my file, the file that we described earlier. It will write, and if my file, it means that if the folder is opened, then it will display a message that is ready to write, and it will write in the folder, data folder of SD card ready to write. Else if there is no SD card, it will display failed to open file message. uh, Similarly, like we saw in the simulation, when the SD card was not inserted, it displayed a message. And then we have introduced a delay of 1000 milliseconds, and then my file will go above, or all the movement functions of the robot. These are already defined. We uh, were not required to do anything from this. Here it is, the data writing functions in the folder. So here it is. If there is a left turn ahead, it will write in the my file folder on the SD card L, print L. L means left, for the left turn. So if my file is open, in case the SD card is in the slot, it will display L message, and L message will be written in the folder. And else if straight path is found, it will print S. S stands for straight, and it will similarly write S in the folder. Else if right turn is found, similarly it will show R, for R stands for right, and it will write R in the folder. And if there is no path ahead, it will move backward, take a whole 360-degree turn and move backward, and it will display B for back, and it will store B in the folder. So this was it. This was the modification that we made in the SD card function and program, which was our project. So this was it from this project, ZUMO simulation project. Hope you liked it. Thanks for watching. Allah Hafiz.